Let's take a look at this example where we have an exponent on our variable inside the binomial that we're trying to take to a power. So we're going to start off the same way we've been starting these problems. We see our n of 3 there. So we go to our n equals 3 row of Pascal's triangle to get our coefficients of 1, 3, 3, and 1. The two pieces of the binomial are 2x squared and 5. So I'm going to go ahead and put each of those here. I have 2x squared with each of these. And positive 5 with each of these as well. Now I'll go ahead and fill in the powers. Again, starting at 3, we go 3, 2, 1, 0, and then 3, 2, 1, 0 back up the other direction. Now it's just a matter of simplifying each of the terms, making sure that we don't make a mistake along the way as we're trying to remember how to deal with powers to other powers and things in this example. So just like before, anything to the 0 power was going to be equal to 1, so I can just cross off those terms there. They're not going to have any effect on this. So now let's deal with the numeric part of each term first. We have 2 to the 3rd power. Don't forget to apply this power to that 2 right there as well. So 2 to the 3rd power, 2 times 2 is 4, times 2 is 8, times this 1 is still 8. And then this is where it gets a little bit tricky with the exponents. Here I have x squared now being cubed. I have a power to another power. Remember your exponent rules from Algebra 1. Power to another power, you multiply the exponents. So that becomes x to the 6th power right there. Then moving down to the next term, I have 5 to the 1st power here, which is 5. Over here I have a 2 that's being squared. 2 squared is 4, so I have a 5 there, a 4 there, and a 3 there. 5 times 4 is 20, times 3 is 60 for the coefficient. And then I have x squared squared, which would make x to the 4th, like that. Next term, 5 squared here is 25. 2 to the 1st there is 2. And then I have the 3 there. 25 times 2 is 50, times 3 is 150. And then I have x to the 2nd to the 1st, which is just x to the 2nd. And then finally down here, 5 to the 3rd is 125, times this 1 is still 125. So now we have our 4 terms. We can go ahead and write the actual polynomial expansion. 8x to the 6th plus 60x to the 4th plus 150x squared plus 125. I don't need any alternating signs or anything here since I didn't have the negative in there. You should hopefully be able to see a consistent pattern appearing there with the exponents 6, 4, 2, 0. They're going down by 2s. You can see how that 2 was affecting that in there. So there's that expansion, and that pretty much sums up how to use the binomial theorem to expand a binomial to a given power.